Hello, in this video I'm going to show you how to use a visual model with a grid to factor polynomials. So factoring is essentially division. It's representing a value that is a polynomial, it has variables in it, as a multiplication of two factors or more. So we're going to start with an example that has some small values in it. So we've got x squared plus 5x plus 6. This is a trinomial because it has three different terms in it. It has an x squared term, it has a linear or single x term, and it has a constant term of 6. So the first step in this process is to represent the x squared term as a little square. And the dimensions of the square are not important. I'm choosing to make it a 2 by 2 just to use the page efficiently. Okay, so I've shown x times x, making a square of x squared. And then I'm going to skip over that term in the middle and go to the constant term, because the constant is a fixed value. It's a number that I can count. So I'm going to think of how can I separate 6 into two factors, into two values that multiply together to make 6. And I can do that with 2 and 3. So I'm going to show 2 times 3. I'll do this way, 3 lines and 2 lines. Okay, so I've drawn the lines in this manner, intersecting vertically and horizontally, because I'm using the grid lines of my paper. In another video, I'll show you how to do Chinese multiplication technique, which the lines are just on plain paper, so you're not required to use a grid, but it's a similar concept that the intersections represent values of 1. So 6, I've got 6 little intersections of those lines. Okay, so at this point, what I've got drawn on here represented is my x squared and my plus 6. The next step is to continue or to complete the rectangle in this case by extending each of the lines that I've already got. So I'm going to extend this side down and this one across. I just completed that rectangle. I'm going to extend the verticals of my 2 times 3 up, and I'm going to extend the horizontals of my 2 times 3 over. And you can see that I've just completed a little rectangle. So the fact that it does make a rectangle means that this polynomial that I was given can be broken into two different factors of length and width, or in this case, the distance across the top of the rectangle and the height of this rectangle. So the distance across the top here is x plus, and I've got 3 bars, so 3. And the distance or length of this side to the left is x plus 2 bars, that's plus 2. So the factored form of that trinomial is x plus 3, x plus 2. If it isn't possible to arrange it into a completed rectangle with no gaps, then the trinomial that you've been given, or binomial, is not factorable. All right, let's try another one. X squared plus 7x plus 12. So again, I'm going to use just a little 2 by 2 to represent the x squared, to be efficient with my use of paper. So that's x times x. And I'm going to skip over the middle term and look at the 12. 12 can be broken up into 3 times 4 or 2 times 6. And I have to think about 3 and 4 adds to 7, so that's the one I'm interested in. So I'm going to go 4 bars, 3 high, like this. And if you were to count the intersection points there are 12 of them. That's a way that you can verify that you've got it laid out properly. And at this point, what I've got drawn is x squared and the plus 12. Now I'm going to extend each of those lines that I've already got drawn to complete the rectangle. So extending horizontally, there. So what I've shown here, I've got x, this distance, and then 1, 2, 3, 4. And down this way is x, and then plus 3. So the factors of x squared plus 7x plus 12 are x plus 4 times x plus 3. Okay, so both of these examples that I've given you are creating a rectangle in their visual model. Let's try another one. X squared plus 6x plus 9. And I hope what you're going to do is pause the video and try it yourself, and then double check your work. Okay, so I've drawn my little x squared, which is literally a square that is x by x. And then 9 is a square number of its own. It's 3 times 3. So 1, 2, 3. Okay, like that. So there's my grid. So I'm actually drawing in all of the divisions, all of the grid lines for this 9, because I know that I'm counting each of those units making up that 9. I don't draw in the grid lines in my x squared because I don't know how big it is. I know it might be 2 by 2, but it might be 5 by 5. I don't know the value of x, and I don't need to know it in order to complete the rest of this work. Okay, so at this point I'm going to continue the lines to complete this quadrilateral rectangle, which also happens to be a square. There. So what I want you to notice in this case is it completes a rectangle, but it's perfectly symmetrical. You could draw a little line right across the diagonal here, and it is perfectly symmetrical. If that is the case, then you're dealing with a special case where it's actually a binomial squared. So here's what I mean by that. Across the top, the dimension is x plus 3 in this case, and down this side, the dimension is also x plus 3. So the factors are x plus 3 times x plus 3, which I could write as x plus 3 squared. Okay, so when you're using the visual model, if you see that it's creating a perfectly symmetrical with a line of symmetry down the diagonal shape, then you know that you've got that special case of a perfect square. That's one of the reasons that I like using the visual model, is right away I saw that that was a symmetrical shape. Okay, let's try another one. X squared plus 8x plus 12. So this one, if you look at it, it's very similar to the second example that I did. It's got the x squared and it's got the 12, but that middle term is different. And the reason for that is that 12 is actually a very, very rich number. It can be separated into lots of different pairs of factors. You could do 1 times 6, you could do 2 times, what am I saying, 1 times 12, 2 times 6, 3 times 4. So because it has all of those different combinations, that middle term isn't always 7. So let's look at that one. So x times x is still going to be that little square. And don't draw in the grid lines in the middle. And then the 12, I've got to think, how can I break it into 2 factors that will multiply to make 12, but they will add to make 8. And the combination that works for that is 2 times 6. So I'm going to go 6 lines that are too long. There, that's 2 by 6. And so currently all of these little boxes on the bottom right are representing that plus 12. And now I'm going to complete the rectangle by extending each of those lines that I've already drawn. Okay, so now in the constant terms, I've got my 12, I've got my x squared, and I've got 6, 7, 8 bars. So this across the top is a distance of x plus 6, and down the left-hand side is x plus 2. So my factors are x plus 6, x plus 2. So the reason I did that example was to show you that the constant term is not enough information. You also have to consider that middle term when you're trying to figure out what the factors are. In the next video, I will show you how to do similar visual modeling for trinomials that include negative values.